Okay, so welcome back. And so what we're going to do is we're going to do an example of calculating arc length for a particular function over a particular interval. Okay, so here's the function, f of x equals 2x to the 3/2 power over the interval 0 to 1, and we're going to round our answer to 3 decimal places. So the first thing, we want to make sure that this is a smooth function, and it is, because this is differentiable everywhere. Okay. Now also, if we take the derivative, right, so f prime of x equals what? Well, in this case, it's going to be 3x to the 1/2. Yeah, I'll just leave it that way. To the 1/2, which is continuous. Okay? And over this interval. So this is differentiable over this interval, and this is definitely continuous over that interval. Okay, so we're good. So now we can apply the arc length. So we want to find the arc length over this interval of this function, the arc length of this function over this interval to 3 decimal places. So let's just set it up. So we know that arc length is equal to the integral from a to b of the square root of 1 plus f prime of x squared dx. And so now we're going to put in our values we know, which is 0 to 1. So we're going to do from 0 to 1 square root of 1 plus 3x. So 3 times the square root of x, quantity squared, dx. Okay, so now we've got everything in there, so now let's simplify the expression. Okay, so what's going to happen in here? Well, we're going to distribute the 2 using the power rule for our exponents. And so this is going to become 1 plus 9, right? So it's going to be 1 plus 9 times x, right? Because 3 squared is 9 and square root of x squared is x. Okay, and then we have our dx. Okay, so now what do we do with this? Now we've got to simplify. So what can we do with this? Do we have anything in our toolbox that will help us solve this? Yeah, we could do u substitution. So let u, I'm going to do it over here. So we're going to let u equal the radicand, which is going to be 1 plus 9x, which means du is going to equal 9 dx, or in other words, 1/9 du is going to equal dx. And so now we can place this in. So now what do we get? We get arc length equals the integral. Now, we have to change our limits of integration. So when x is 0, u is 1. And when x is 1, u is 10. So now we're going to go from 1 to 10, and then this is going to be the square root of u. Oh, we have a 1/9, so we're going to pull the 1/9 out, du. So now there's our resulting integral. And now let's integrate. So we're going to get 1/9. And when we integrate this thing, we're going to get u to the 3/2, but then we're going to get 2/3 out here because we have to either divide by the new power or multiply by the reciprocal of the new power. So this was 1/2, right? And so we added 1, which makes it 3/2, and so we get the 2/3. Okay? So then now we're going to simplify. Oh, we evaluate this, of course, from 1 to 10. Okay, and now it's just plug and chug now. So this is going to be $227 times 10 to the 3 halves minus 1 to the 3 halves. Okay, and if you calculate that out, and this actually, this here, just if you want to simplify this, this becomes 10 times the square root of 10, because you have 10 cubed, right? So you can write that as 10 squared times 10, and so the 10 comes out and you get square root of 10. So, but in any case, you still get the same answer if you put in your calculator this way or this way. So this is the approximate arc length. And now, here's one for you. You guys try this one. So, let f of x equal 4/3 x to the 3 halves. And we want to calculate the arc length of this function, the graph of this function, from 0 to 1. And we want to round to 3 decimal places. Okay, so go ahead and try that one. And again, if you want confirmation that you did it right, or if you get stuck anything, just let me know. Email me, and I'll be more happy to help you. Take care.